Are you looking for a REVIT family of a parking lot pole light similar to this one? The out-of-the-box REVIT pole light isn't quite what we wanted, so we created our own custom pole light fixture that is parametric. And here's step-by-step exactly how we did it. And stick around to the end where we'll show you how to create a two-dimensional symbol that's annotative. Let's get right into it. So here's an actual photograph of what we're looking to create. Now this is an older style fixture. As you can see, it has large heads up top, which were most likely metal halide or high pressure sodium back in the day. But it shows that we have in this case, a tapered round pole. And we've got arm mounted fixtures up top. This is a twin. And if you look at this other one nearby, there's a triple, all 90 degrees from each other. The pole foundation, some people call it a pole base, but the base is actually the wide base of the pole itself with a base cover. The foundation is this big concrete monolith with rebar and anchor bolts and things like that. And in some cases, when you're in a parking area, you might have 2 or 3 feet of concrete above grade to protect the pole. And then down below grade, there's 4, 5, 6 feet typically of foundation going straight down underground. And so this is what we're trying to achieve. Now these fixtures typically have a little handhole cover. We don't need that level of detail, but we can catch most of the other things. Now the trickiest thing in this fixture will be this tapered round pole. Now shorter poles often are a straight round pole that's just the same dimensions the full length, or you of course can have a square straight pole, but I wanted to add a little bit of complexity to this so you can get the hang of some of these family editing tools. Now, some of the features we would like in this custom family is I would like to be able to adjust the height of this foundation above the grade. I'd like to be able to adjust how far underground it is. I'd like to have some control over this bolt cover size and, of course, control over the pole diameter, both at the base and at the top. We need control over the pole length. And I would like control over the mounting height of the fixtures because sometimes they can be mounted a little bit further down on the pole, and we want to be able to get specific with the bottom of the fixture as the mounting height. I would also like to be able to adjust how many heads are on here in this one family. So I need some controls to add 2 or 3 more fixtures so I can have a total of up to 4. If you want to get really fancy, you could even get to the 120 degree mounted 3 fixture, but I'm not doing that in this case. We can save that for a future family. And another feature I would like to have is I want this fixture not to be hosted to anything. I just want to bring it in. It's going to land on the ground at the grade level, and then I can adjust it up and down however I like without being attached to anything. And we of course want all the electrical features. We want adjustable voltage and poles and load. And also, when I put this into my 2-dimensional site plan, I actually want it to be a symbol that's the same size no matter what scale I'm at. So we want a 2-dimensional annotative symbol. So there's our list of what we want this family to have. Now, my first thought on this was to just use a family that's already been created, that's available. I could use a manufacturer's website for that, but I also want to look at what does Autodesk actually have out of the box that's available. So what I've done is I've downloaded one of their site lighting fixtures. Let me just show you where you can find that up here under the Load Autodesk family. If you'll start out with all results, you go down to the lighting and do not do architectural lighting. It has no electrical connectors. Go to MEP. And if you scroll down enough, you'll find down here, they have a streetlight antique and a streetlight standard. We're looking for kind of a standard look, so I load that. Okay, let's go down to our lighting fixtures, and we'll see that he is down here. Streetlight standard, just pull any of these in to take a look at it. Now, there's our symbol, and we can rotate it around with the space bar. Let's put that in. So that's kind of what the symbol looks like, which is okay. Got a nice long arm, a round head. Let's see what this looks like in 3D. Yeah, it doesn't look bad. It has a little bit of a foundation here. And it's kind of an older style, larger head, maybe like a metal halide, but that would work. If we're fine with this look, this would work. And maybe this is what you want to be your starter in your template. And if you click on it, it does have electrical connections. You take a look over here. We can actually change the load. We can change the number of poles. We can change the voltage. So it's very customizable. So electrically, this would work. Now, what it doesn't have is it doesn't have any additional heads that we can place on it. The pole is a straight square, which is fine if that's what we're looking for. If you look over here, there's no adjustment for any of the height or anything like that. So we can see that it is hosted to the floor, to level 1. So we can't move it up and down. This is just a default elevation. We do have control over the voltage, number of poles, and the load, which is good. We have a height adjustment, but that must be the height of the full assembly. So change it to 20 feet, and it pops it down. So it's 20 feet. If we take a look at elevation, here's our thing. Yeah, we got 20 feet. So it's from the bottom of the base to the top, not the rounded, but the squarish top of the fixture. So it's kind of a relative height. We normally have heights to a fixture to the bottom of the fixture, things like that. So that's a little different. We just have to deal with that and adjust it appropriately. So again, this would work in some simple cases where you need one head and you just need to connect it electrically. But again, we want to have some more features in ours. So let's get into our editor and start working on this. What we're going to do is we're going to create the head or fixture by itself, and then we're going to nest that fixture multiple times into a complete pole fixture family. So we need at least 2 families. And then when we do the symbol, we'll have a 3rd family. So let's start off with modeling just the fixture head itself. And so for the head, the fixture heads, or the luminaires, as sometimes they're called, I want to use this kind of an area luminaire. This one's made by Lithonia, which is a large manufacturer. And this kind of shows you the modern type of LED fixture we're looking for. It has a built-in arm, and it kind of has this sleek design. It tapers, it gets larger here and tapers down. And even from top view, it's wide here and gets narrow. So it's a complex geometry. We're going to simplify that for our purposes, but I just want to show you this is what we're aiming after. And you can see there's different sizes. Now, because it's going to be complex geometry, I'm not going to be able to make it parametric so that we can have different sizes. It's hard to stretch this complex kind of extrusion, so I may have to have 3 different families, but I'm going to go ahead and make this a smaller one. And then the actual cut sheet download is right here. And this has dimensional data that we can use to get our fixture, at least approximately the size of the actual fixture. So you can see here is the top view, and that's a complex shape that we're going to try to create. We're not going to try to create this vertical shape. So what we're going to end up with is more of just a rectangular look that may be something like this size. For our purposes, that will be sufficient. The 3D views that we do aren't architectural renderings that need to be exact with all the heat sink fins and things like that. So this will be close enough. But this will give us the basic idea of dimensions. So if we go down and look at some of the dimensions, this is all the performance. So yeah, here's our box we're going to draw. And this one is about 28 inches long and about 14 inches wide. So we want to keep those in mind. And it's around 2 inches high. Nice and sleek. So we are going to be drawing a extrusion that's that kind of dimensions. So enough of this. Let's get right into Revit and get started. We're going to start a new family from scratch. Now, what family template should we use? Well, we're English and Imperial here in the US. We could use a lighting fixture, and it will have a light source within it. We don't need the light source in our situation because we're outside. We're not going to have a space to do zonal cavity type area calc. So we're just going to use a generic model that doesn't have that light source in it. And then we can easily change it to be a light fixture category. So here we are in the editor. Up here at the top left, we have a little folder, family category and parameters, family category, generic model. We can change this to be a lighting fixture. Now, what does that do? Well, it just means that it sorts as a lighting fixture in your project browser. You can turn it on and off. You control visibility by category when it's a light fixture. So you want it to be a light fixture, and we're good with that. There's no light source in it. So what this is, it says reference level, floor plan. So it's a top-down view. So this is the top of our fixture, and we need to decide how we want to orient this fixture. we definitely want the insertion point, the cross of these two reference planes, to be our insertion point. So we'll make this the end of the arm, the back of the arm that will attach to the pole. And so I'm going to have the fixture aimed down such that when I do front elevation, I'm looking at actually what I would call the front lip of the fixture. So that's how we're going to orient this. You want to have this all planned out before you start drawing anything. And let's go back to this PDF and take a look at this. So what I'm calling, this is the front view, and this would be the left side view. And let's go up to our overhead view. Here's our top-down view. So we're going to actually turn this fixture so it's facing down. So let me just do that with this document. Okay, rotate pages. And we want to go clockwise, 90. This is in Bluebeam Review. So this is how we want our fixture to be. So this is going to be our insertion point right there. We'll create some boundaries in here with reference planes, and then we'll draw this geometry with reference lines. I'll show you how that works. We're going to bring this PDF into our family so we can trace over it. So what you can do is go up to Insert and import a PDF. Will not be visible in projects. Yes, it's only visible here, and here it is. So we'll bring this in, and it says, which page do you want to bring in? I'm just going to bring that first page in and just set it in here somewhere. There we go. So now I want to make sure that this is scaled appropriately. So I want my overall dimension to be about 28 inches is what we looked at. So let's draw a line that is 28 inches. Let's see how far this is. This one is 3'2", and we want it to be 28. So let's see what the ratio is. So 3'2", 36, 38 inches. So we want 28 divided by 38 is 0.736, 0.737. We could go 0.74. So let's try n equals 24 times 0.74. Now we can make sure we got the right size. There's our line. Let's redraw our line from here to here. So we're at 2'3", 2'4", 28 inches. So that's what we want. Now let's drag this over. And we can actually use a move command. Click on it, move, and we can pick points. Pick a point there, pick a point there. And that's roughly centered. What we need to do now is draw this geometry with references. First of all, do we want to use reference planes or reference lines? We have both. What's the difference? Well, a reference plane is like these two planes here. They are a flat surface, definition of a plane, that goes on forever. So it's always a flat three-dimensional surface. So a reference line is just a two-dimensional surface, but as you can see, a reference plane, you can only draw a straight line. But a reference line, you can draw in many different shapes. We are going to need some curved shapes to trace this shape. So we're going to use the arc tool, reference line. So I'm going to start with a line from this point, and it starts to curve about here. So we'll stop that. And it's kind of hard to see it, it's so little. Let's turn thin lines off. There we go. And the other thing is we're only going to draw half of this from this line to the left, and then we're going to mirror it so that it's symmetrical about this axis point. So let's go to Create. This time we'll use this start end radius arc. You also have center end or tangent end, so I like the start end radius selection. Just a different way to draw an arc. And this curves here and ends about here before it changes direction. And we may take a couple times to get this right. Now what happens is this will snap to the tangent. It'll kind of pop, snap right there. That looks pretty good. It knows that we want to continue on from this end, so we'll go with that. So this curves, this radius curves about to here before it goes straight again. About to to here. There we go. So let's see. It's a little shallower. but I think that'll be close enough. Again, this is just, we're just getting close. We don't want to mimic this fixture appearance. And this actually doesn't turn straight enough yet. See that I have to go that far to turn straight. So I'm going to redo that one. It may take a couple tries. I'm going to start there and end somewhere in here. And then I can start there again and end, and maybe I can get this to, there we go. That's a little more of a curve that I want. And it puts me at more of a straight line. So I can go here with a straight line, continue this down. Now I want to have a sharp bending arc to finish this off. Go with another arc. And this guy will go to here. And we just need to kind of make it look horizontal at the bottom here. Something like that. Okay, and then up here we have another straight line. Here to the center. There. Now we want to mirror this shape about this axis. So if you hold over one, you'll just get one of the lines. If you hit tab, it will select the entire chain of lines. So click on that. Now I have all of these. I want to use the mirror tool with picking an axis and pick that as the axis. I also have copy left on, which means I want to copy these over here. I don't want to just move them. And there we go. Now I can pull this out of the way and we can see what we've created. So there's our shape. Absolutely symmetrical. Now this is just reference lines. There's no 3D to it yet. But this is the skeleton of our extrusion that we're going to build. So now that we have the shape created, we want to create an extrusion, it's called. You have these different shapes you can create. Extrusion is just stretching a shape from the 2D up to 3D. Now a blend, we will look at later. You can have a different shape at the bottom than you do at the top, and it will blend it together. And then there's revolves, which are circular, and sweeps, which give you different kinds of shapes. If you want to draw something like what they're showing here. So the different kinds of shapes. We're going to use a simple extrusion for this. So an extrusion, we're going to extrude this shape up 2 inches. Now the default, when you go to extrusion, the default is to have a depth of 1 foot, which is fine. We're going to move it later anyway. So leave it at 1 foot depth. Right at the bottom it says, click to enter line start point. Now I can start drawing lines, but I already have them drawn, and that's why I drew this as reference lines, so I don't have to redraw them. So instead of tracing over this, what I can simply do is go to this button here called Pick Lines. It creates a line based on existing lines. So if I click that and I hover over, I'm going to use that as my line. Now I don't just want one, I want the entire thing, so I hit Tab. Now I got the whole chain of lines and arcs that I'm going to pick as my boundary for my extrusion. Click on that. And then I want to lock my extrusion to every piece of these lines and arcs. So lots and lots of little padlocks. That way, if I decide to change the shape of this in this family editor, because I'm not making this parametric, I can do so. So that's all locked. And then I can just say, okay. And what it did is it actually created an extrusion. Now let's look at it in 3D. There it is. And we can change the look of this 3D, give it some shading. There's our fixture. Now, of course, it's too tall. So what we need to do is go to the front view of this fixture. And we need to set a height. Remember, we do want this reference level to be the bottom of the fixture, so we're good there. We just need to create a height. So let's go over here, and this time we want to use a reference plane because we want a straight line that goes on forever. It's not just a thin line. It's actually a flat surface. And we want to dimension this. Now, be careful here when you dimension to this line. We don't want to dimension to the reference level. There's two things stacked. There's a reference level stacked on top of the little green dashed reference plane. So we want to hover over here and hit Tab to select, and you'll see reference plane. I want to dimension from the reference plane, not the reference level. If for some reason we ever decide to separate the plane from the level, I don't want this level screwing up our family. So there. And then to this other reference plane. So we're dimensioning from reference plane to reference plane. And then here we are again. We can set that dimension to 2 inches. Now we want to align this top of this extrusion to that dimension. So let's go up to our align tool right there. This is align. And then you want to align to this from there. See how that? To this from there, and then lock it. So now if I were to move this around, you can see my extrusion goes with it. And that's what we want. And this is good. It's called flexing your model when you try it out. Flex it, bend it, see if it works. So we'll go back to our 2 inches. So we also need to lock the bottom of this extrusion to this reference plane, not the reference level. So hit the align, get over top of this and hit tab to get the reference plane, and then click on the extrusion and lock it. So there we go. So that is what we want for our extrusion. Simple as that. We don't need any fancy heat sinks or anything like that for our purposes. We're doing what I might call a Minecraft level of detail. It's pixelated somewhat. It's not ultimate 3D rendering detail. So we're done with this and we want to save this. So save as a family. And I'm going to call this, it's a light mounted fixture. I use the word fixture. Some people use luminaire. They're interchangeable. Light arm mounted fixture. And we'll save it with one backup. Okay. Save that. So now we have this fixture made. Now we want to create the rest of the family, which is going to be the pole base and the pole and all that. So we need yet another new family. This is a more complex project, which will have multiple pieces. So this family, we're going to go English Imperial, and we're going to do, again, a generic model that we will change to be a light fixture. Now, even though this is a pole and all that, it's going to be on the site, I still want to consider it a light fixture category. So again, we go up to our category and change it to a lighting fixture. No light source. Okay, so let's see what we want to create first. Going back to this photograph, what we're going to do first is create this foundation. So it's going to be a circular foundation. We'll need a reference line in the shape of a circle, and then we'll need a depth. And I would like a separate height for above grade and a separate height for the depth below grade. So let's create that. So we need a circle, and we're going to do this with references. Now, again, reference plane, we can't draw any shapes other than a straight line or a plane. So we really need to create a reference line. So let's use the circle tool, reference line. So we're going to do a reference circle. We're going to center it here. And again, we're looking down from the top in this reference level top view. So we're looking at the top of this foundation. Center it, and then just put a circle out wherever you want. And then we want to make sure this circle stays locked to the center point. So you can't really use a line with a circle and get it aligned. What you need to have is a center mark for this circle. So if you go to the right, you can see center mark visible. Turn that on and you'll see this little cross, little plus sign in the middle. Now we have something we can align to. So now we can use the align tool. We want to align to this vertical from this center mark and then lock it. And then again, we want to go to this horizontal from this center mark, lock it. Now that's locked. Now if we try to move this circle, we'll get an error. It says it's constrained, which is what we want. Another thing you may notice is that these can be named. In fact, this reference plane is called center, left, right. It has a name, but you cannot name a reference line. In this case, a reference. So there's no way to name it. Just a little note to keep track of. Now we want to dimension this circle, and I like to use the diameter. So we can go to annotate and there's a radius or a diameter. I want to use the diameter in this case. So click on that circle and click it and orient this however you want. It's just visual. Click anywhere off of the circle. And now I have a dimension of that circle. Now, escape out of here. If I click on the dimension, now I have a chance up here to add a label. I can name this dimension. Now I want to name this dimension and give it a parameter so that I can control this diameter of this pole foundation within my project later when I put this in there. So up here, go to create a parameter, And these are all family parameters. We don't need them as schedules or tags. I'm going to name this foundation diameter. I like to use descriptive names so the users have no question what this is. Type or instance. All these parameters I want to be part of the fixture type. It depends on how you use these fixtures. If you use a pole fixture so that the pole is one name of a fixture, type SA, and then the fixture head maybe an SB, and you do things like that. The way our firm does it is each pole and fixtures all together is called one fixture type. So I'm going to make all of these type parameters. And then grouping under dimensions works for me. I like that because these are actual course dimensions. So I'm going to leave it as dimension group. That's how it shows up when you look at the type parameters box. Okay. And for example, if we go to the family types, you will see that the foundation diameter we just created shows up under this dimensions heading. So we want to group all our dimensions under here. And then from here, we can actually change that diameter using this parameter now. So we're going to make it be 2 feet for now. I don't like all these words in the middle of my family, so I can click on this and you'll see there's a grip in the middle, but there's also a grip right under the text. If you grip that and drag it, you can move that dimension out of the way and it's hooked with a leader. You can also change the scale of this just to make the text smaller and out of the way. It doesn't affect anything. But now we want to add the vertical dimensions. So let's go to our front view. Again, like the other family, we have this reference level, which will be our insertion level, which is going to be the ground or the grade in our case. So this is going to be the grade level, and we want our foundation to extend above it and below it. So we're going to need some references for those. So let's go to reference plane. Now we're doing planes now because we want a flat surface, and we want a top, and we want a bottom. Now, if you want this line to be longer, it intersected. I mean, it does, behind the scenes, it intersects. But visually, if you want it, you can typically click it and drag it. However, these are pinned. The center is pinned. So you can unpin it temporarily and then use the grip to drag it down. And then I would repin it like that. You don't want that moving around. Now let's get some vertical dimensions. Again, we want to tab till we hit the reference plane, and then go up to the top, and we will call this one, we're going to give this one a parameter name as well. We're going to use a lot of parameters in this. We're going to call this foundation above, because the other is going to be foundation below. Type dimension is good. And then we also want one, tab through, click on that, and I'm going to line it up there just visually. And we'll call this one, add a parameter called foundation below. Under dimensions, we're good. Okay. And if these intersect, it's hard to read, we can move this out of the way. Now we're set to actually create an extrusion and lock it to all of these dimensions. So now we have our skeleton in place. So let's go back to our reference level where we're going to draw our extrusion. So go to create, and here we are again, extrusion. Now this time, the shape we want is a circle. Now we could just hit circle and draw it and try and align it, or we can use that pick line since we already have a circle drawn. Use pick lines, pick on that, pin it. It extrudes it 1 foot high. So we're done with that. Let's see what we got. Let's go to our 3D view. And I like to name this 3D view instead of view 1. Keep track of where I am. So there we are, and we're going to get back to a shaded. So there's our extrusion, a round extrusion. Now let's look at the front so we can fix the dimensions. We want the top to be up here. So let's go align to there, from there, lock it. Align to there, and this, we are touching the extrusion. You have to be careful when these are stacked that you're not hitting the wrong thing. So hover over it. We are doing the extrusion and pin it. And now let's look again at our 3D. There we go. If you're getting some value out of this video, I'd sure appreciate you hitting that thumbs up like button down below. And if you want to see more electrical only content, hit that subscribe. I appreciate that. Back to the video. So we have our foundation created, and let's flex it. Let's make sure it works. Make sure that that extrusion, we're good there, is stuck to that line, and it is stuck to that line. Let's check the circle. If we were to change this foundation diameter to 3 feet, the extrusion went with it. We're all good. I like to flex the family after each major creation point. You don't want to wait till later. It'll be hard to troubleshoot where it went wrong. So flex it frequently. Sometimes you can even load this into your project and flex it there to make sure your parameters are working the way you want them to. The next piece I'd like to add is the bolt cover. As you can see in the photo, there's this square sheet metal type of cover that actually covers the bolts that hold down the pole. Sometimes these can be round and they have a rounded shape up top, but in this case, this is kind of just an industrial look of square. We're just going to do that one. So back to our family. So this time we need some more reference planes for this square, top and bottom, left and right. And then we want to dimension these. And I want to give this a parameter as well. We're going to call this bolt cover size, something like that, and under dimensions. So we're giving the user lots of parameters so they can adjust this the way they want. You can go too far with that if you have too many parameters, so you have to find a good middle of the road. So we'll see how this goes with the users. If it becomes too cumbersome, we can back some of these off. But I'd rather have more control than not enough control, frankly. So bolt cover size, and then we also want to make this centered, so we'll do the equal thing again. Get the EQ, that centers it. And we want the same thing here. So a line dimension here. I wanted this to be a square, so I want it to be the same size as that one. So what you can do is you can reuse a parameter that you've already created. So instead of creating a new parameter, I'm just going to select one that I already made, bolt cover size. And that forces these both to be the same. And then I'll do the equal. I just throw these on opposite sides to keep them out of the way. So there we go. And our bolt cover size is going to be somewhere around maybe a foot. And you can confirm this with your cut sheet of your actual fixture you're using. But for now, we're staying generic. So there we have 1 foot square. And I'm going to put my foundation just to get it approximate size. I'm going to make it at 2 feet just to get it a little more accurate there. We have the skeleton of our bolt cover. Now we just need to do the vertical dimension. So let's go to our front view. And we need another line up here. Now we can just go to create similar, add another reference plane up here, and let's give it a dimension like that, and give it a parameter name. This one's going to be bolt cover height. We'll give them control of that as well. And we'll set that one to, let's go 6 inches on that height. So now we have the dimensions we need. Now, before we create the extrusion for this bolt cover, I need to talk about work planes. As you'll notice, when we create an extrusion, over here on the right is a work plane area. You can set the work plane, show the work plane, and what that means is which one of these reference planes do we want to start the extrusion from. For example, if we wanted to go a horizontal extrusion, we would need to set our work plane to this vertical plane. Or we want to start our extrusion from the top of this foundation on up, we can set the work plane. Now, of course, we can just create the extrusion down here and then move it up. But this is good practice for establishing a work plane to work from. Now, there's different ways to pick your work plane. If you go to a 3D view, you can set your work plane by name or picking a plane, and we can kind of hover over these. And so we could pick this plane right there to be our work plane. The other thing you can do is you can name a reference plane and select it by name. So in this case, I want to show that example. So what I'll do is I will name this, click it to name. I'm going to call it foundation top. And that's the name, not of a dimension or a parameter in this case. It's the name of an actual reference plane. So now when I go to my reference level view and create an extrusion, before I create the extrusion, I'm going to set the work plane to the foundation top. See how it drops down on the list. Now my extrusion will start at the top of the foundation and go up from there. So extrusion, I want a square extrusion, this guy. If I use pick lines like I did before, I'll get the entire plane, but I can trim it. So let's try that. I'm going to pick all these planes. You can see that the pinkish, purplish line extends all the way. And then I can use tools like trim extend to corner or trim extend multiple elements. So I click on this as the trimming. This is the cutting line. And then I want to keep this piece of this line. I want to discard that piece and keep this piece. Do that. And I want to keep this piece. So I can do the same again. I can just go through and trim all these lines. I want to keep that, trim. This is my cutting line now. I want to keep this side of this line. And then use the trim here. Save that, save that. Now I have a complete closed shape that I can use for my extrusion. And the last piece of this is I actually want to lock this shape to these lines so that my shape moves with them. Well, to do that, I have to go back to now my align and align it and then pin it. So align to there, even though they're already on there, from there, I still need to align them to get this lock to show up. To there, from there, lock it. Now we're all locked in this dimension and say, okay. Now go look at my front view and you can see my extrusion started up here rather than down here. Now I want to align the top and bottom to these reference planes. There, everything's locked. If I move this around, I get a stretch. So everything's pinned together. Undo those. Go back to my level and see if I move these around, my box changes. So there we go. Okay, so next we are going to work on the pole. So let's go back to our reference level and we are going to do a circle pole. So let's get the base diameter, the bottom diameter of this pole. To do that, of course, we need a reference line that's a circle like we did for the foundation. So circle, and we're going to center it here. And let's pull it out. Oh, for now, we're going to say it's going to be an 8-inch base pole. And we can just put it anywhere. We're going to dimension it later. And we want to pin this pole to the center line. So again, we need to turn on our center mark visible and then use our align tool to align it to here. And now it's luckily picking the most recent circle that we drew because they're stacked right now. And we would have to tab through if it wasn't. So we're good there. Now that circle is centered, forced to be centered. Now let's put a dimension on it. Let's go up to annotate and we want a diameter dimension on this circle. Right there, and let's pull that one off this direction and get that out of the center. Oop, I missed it. Grab that one out of the center. We want to add a parameter to this. This one's going to be pole bottom diameter. Pole bottom diameter is what we want, and it's under dimensions. Now, just a note here, if we were just doing a non-tapered, straight, round steel pole, for example, then that's all we need. And we can just create our extrusion from there. And you may want to go that route to keep it simple. What I want to show is how to do a tapered pole using a blend. So we are going to do yet another circle for the top of this pole, because as you see, the bottom let's say it's 8 inches, the top may end up being about 4 inches in diameter for those arms to mount to. We need to do yet another circle. Create, reference line, circle, same thing we just did. And this will be smaller. We need to center mark it, do the same things we just did, and align there to there, lock it there to there, lock it. Okay. And then we need dimension in there. We still have our last diameter dimension up. Pull it over here. Get you out here, and let's label this one with a parameter. Pull top diameter. Okay, so now we have the top and bottom pole diameters set up. Now we want to create this special extrusion called a blend. Now a blend creates the solid 3D shape that changes along its length. So it's going to first ask us to select the bottom shape, and then it will tell us to have us select the top shape. So if we hit blend, all it says is click to enter a line start point. Not very helpful. What are we drawing? Well, a clue up here is you can change, with this button, you can change it to be the top of the blend. So by default, it means we're right now editing the bottom of the blend. So it's similar to extrusion. We need to pick our shape. We already have our larger circle here. So let's just use pick lines, select the larger circle, and lock it. Okay. Now we're done picking the bottom shape. Now we want to edit the top shape. Now we want to select with pick lines that smaller diameter and lock it. And we're done. And we had the default of 1 foot. So let's see what we got. There we go. We started at the top of the foundation, which is what we want. And you can see this tapers up. And in 3D, there we have this little cone type taper. Now we just need to stretch it out to be the right height. So if we go to our front view, now we need a height. Let's go ahead and unpin this and bring it up just for visual help here. And repin it. Now let's get a reference plane for the top. So let's go up here and create a reference plane up here. That'll be the top of our pole. And we need to dimension that. So dimension it. Now the pole length is going to be from the top of the foundation to the top of the pole. So let's get a parameter on here called pole length. I won't say height because that'll get confusing with the mounting height of the fixture. So we'll go pole length. And you can order pole lengths, 20-foot pole, 24-foot pole, 30-foot pole. That's the standard dimension that we want to use. And let's just set this guy down to, let's just go with a 20-foot pole for now. And then we want to lock this blend to that. So let's go align to the top and pin it, and then align to the bottom of it. We're on the blend shape handle, which is what we want. Now that's locked, and let's just make sure that works. It does. And let's make sure the top works. And it does. So we're good with that pole, and it looks nice in 3D. Now we're ready to get those fixtures in here. So let's go back to our reference level, and we are going to make sure we save this. Go ahead and save this before we do that. Pole with fixtures. Save that. Okay. We still have it open, so we can go back to this. Now we can just do load into a project. Now we don't want it in our template that we're using. We want to put it into our pole and fixtures family. So there we go. And it comes in aimed down like we want. Now where are we going to put this? We want it to attach to somewhere near the top of the pole. Now if we put it, this is our top pole diameter, is this little guy. If we do it like this, then we have a big gap. So what I'm going to suggest is we pull it into here, something like that. And it will just blend together visually. So let's hit space bar to get this turned and get another one in here. And I want this to be on this center line and pulled in about to there. And then another one there and another one there. I'm not going to lock these into dimensions right now because they should stay where they are because we're not moving things left and right, just vertically. Now the vertical point is a good point. We need to get these shown vertically properly because we go to the front, they're all down here at ground level. So we need another dimension up here for the bottom of the fixtures, which will be the fixture mounting height. And mounting heights are typically above grade. So let's get another reference plane. And let's get to the bottom of the fixtures. And we need to dimension this. Now we're going to dimension this one from grade. So the reference level, but the plane, the reference plane, up to here. Pull it off to the right. We will call this with a parameter, fixture mounting, if I can spell, height. Okay. Again, this is all part of the type of that fixture pole combination will be its mounting height. And then we can move these up there. So we want to align the fixture, align to there from, select the bottom of that fixture right there. See how it went up? And we want to lock it. Okay, so we want to do it again. Align to there, from there, and lock it. Now we have these kind of stacked on each other, but it's working. It's selecting the closest one, which works. And lock it. And then again, let me stretch this out a little bit so we can get to it. There we go. Align to there, from there, and lock it. So now these fixtures should all move. Flex it. There we go. So now that looks like a finished pole with fixtures. However, we are not done. Don't go anywhere yet. One of our criteria was we want this family to be able to have from 1 to 4 light fixtures, and we want to make it easily selectable by the user. So we're going to apply some simple on-off visibility controls to these. So from our reference level view, now one thing you'll notice is I can't see the light fixtures. Well, even in families, there's a built-in view range that we cannot adjust. So that's why they give us this ceiling plan view, which is starting wherever their cut plane is, looking up. So let's go to that. Now we can see the fixtures. This first one we have in is fixture number 1. We're going to set it up so we always have one fixture, otherwise it's just a pole. So that's going to be the default. However, this fixture we'll call fixture 2 and fixture 3, fixture 4. We want these to be on or off. So what we can do is click on that fixture. We go over here to the visible button. And right now it's just on or off. We want to map it or associate it with an actual family parameter. So on this tiny little button to the right, click on that, and you'll see the associate family parameter. We're going to associate that on-off with a parameter. So we don't have one made. We can't search a parameter. We need to actually create a new parameter. And we're going to call this just fixture number 2. I'm simply just going to let each fixture be on and off. Because you may want 1 and 3 on, so they're 180 degrees apart. You may want 1 and 2 on for 90 degrees. You may want all of them on, or 3 of them on. So I just want it ultimately adjustable. Again, I want it to be a type parameter, and I don't want it under other. I want this up here under, let's say it's under graphics. Now it already knows it's a common discipline and a yes or no type of parameter because it's a visibility on-off. Say OK. Now let's do the same for fixture number 3. Over here, visible, far right little button, create a new parameter, fixture number 3. And we want this to, don't forget to put this up to graphics. Okay, and then same with fixture number 4, visible, associate, new parameter, fixture number 4, under graphics. There we go. Now I can't test it in the family. We will have to test it when we load it into our project, but those are set. Another thing I want to do is I want to make sure that when I'm in a plan view, I don't want all of this extrusion to show up. Some people might like for the family to look like the actual extrusion. However, sometimes if you have a large enough scale, the extrusion will be too tiny to see in plan view. So instead of that, we use symbols. Just like junction boxes, receptacles, we use a symbol that's always the same size on the sheet, no matter what scale the actual drawing behind it is. So because of that, we want to make sure none of this geometry shows up in a plan view or even a course view. The way we do that is it's easiest to select everything in a 3D view because of this height difference. Select everything, but filter it out so that we're only selecting the extrusion, which are called light fixtures. So we don't want reference lines, we don't want dimensions, we just want the lighting fixtures, which are 7 pieces. So okay, we're filtered out to just light fixtures. And then over under visibility graphics overrides in the family, you get this little box. Visibility settings, view specific display. So display in 3D views, and do we want it to show up in the plan or reflected ceiling plan? No, we don't want these extrusions we've selected to show up in the plan. Front and back's okay, left and right's okay, so elevations, things like that are fine, sections. And then detail level. When we're at course, we want it to be as simple as possible. We do not want any of this 3D stuff showing, so we'll turn it off in course. So that sets up some display settings, which is very important. We're essentially done with this part of the family. The last piece we need to do is get the symbol. Let's save this. A symbol is a 2-dimensional annotative object. So again, it's same size in every scale, like a receptacle is. If we were just to go to the reference level and draw over this, it would be the same as having the extrusion. It would get scaled. And I just want to call your attention, that's how the out-of-the-box fixture works. So if we go back to this, what we're going to do is we're going to create a separate family that's an annotation. So one more family to create. Go up to New Family. This time, English Imperial, we want an annotation. Again, annotations stay the same size on paper, on the sheet view. So let's go to Generic Annotation. It's not a tag, it's just a generic annotation. And this here is just a little note saying that this is the insertion point and you want to change the category if we need to. We're fine with generic annotation. So delete that. It's only 2-dimensional view, so this is a sheet view, and this is the intersection point. Now, we want a symbol for the pole and the fixture head. I don't need to have parameters to these dimensions. I'm not going to be changing it. This is just going to be a set size. So I don't need any reference planes or circles. I'm just going to start off. Now, what I want is a solid circle for the pole, so a filled region. And I want it solid black. And then we want a circle. So let's go here. This is the center line. Now I want this circle to be about a 1/16 of an inch in diameter. So that would be a 32nd of an inch in radius. And that's about the smallest you can see. I can't go any smaller. It's about the smallest you can make is a 32nd of an inch. And click done. We have a solid. And I'm going to turn thin lines on. Now I want to create a little arm and a little box for the fixture. This is just a symbol. So let's go ahead and create a line right here. And we're going to leave it generic annotation. Now, if you have a custom subcategory that you use, we can use that for a line style, but I'm going to use generic annotation here. And we do want a line from here, and I want to bring this out. Well, let's make this 1/8 of an inch. All right, and then I want this box to be an 1/8 of an inch box. Straight lines. And I'm going to go a 1/16 of an inch this direction. And then go the same over here. Make it an 1/8. And then draw another 1/8 of an inch. And then I'll just copy these. And copy from here to here. Copy from here to here. So there we have our box that we want. And that's simply all we want. And I have it the same orientation as our fixture. So let's go ahead and save this as a family. And this one's going to be a symbol, arm mounted fixture. And it's just a symbol. You want to have a good naming convention for these things. And then I'm going to insert this, load this into my pole and fixture. So there it is. Now I'm going to bring it into the center. And then I want to put another version of it over here. So I'm going to create similar, rotate it, help it snap there. I find that if I create similar each time, it snaps better. Snap it. It doesn't snap as well unless I create similar. So now I have those. Now I also want the visibility of these to be controlled the same as I do the heads. So for example, I want to put this guy's visibility on that same parameter of fixture number 2. So I can use parameters I already have instead of creating them new. Fixture 3, visibility, assign it or associate it, map it to fixture 3. And then fixture 4, same thing, associate it with fixture 4. So now everything associates properly. And let's save this. Now let's not forget the most important part of this whole family is to get that electrical connector in there so that we can actually hook it up. Go up to create and go up to our electrical connector. Now this wants to land on a surface. So what surface should it land on? It really doesn't matter because it just shows up in your plan. But I typically try to pick something towards the center, and it may want a 3D view to do it. So let's put it on the top of this foundation right there. And then we need to take the parameters in here, fix them up, and then we need to map them or associate them with family parameters so that the end user can see them in the actual model. Because right now they're only visible within this family. So first of all, the main key here is to get any kind of load, with very few exceptions, but any kind of load, make it balanced. If it's unbalanced, you will see you have 3 separate loads that you need to enter for a multi-phase, multi-pole type of load. We don't want that. We just want to put one load in here. So balanced, and then we only have one place to put a parent load, and it gets balanced or equally dispersed across the multiple phases. So we do want to have available to our end user the voltage. So we will go clear to the right, the little associate again, like we did for some of the other dimensions. We want to create a parameter, and there's no parameter for voltage yet. So we will go down here to new parameter. We can call it volts, voltage. And we'll go voltage. And then it's also a type. And you can group these under different electrical headings, but I like to put them all under just electrical because you can go circuiting, lighting, loads, analysis, engineering, and let's just keep it all under one electrical group parameter. Okay. Okay. That is now mapped or associated. I also want to associate my number of poles so that I can create a 208 two-pole light or a 277 single pole or even a 480 two-pole. So let's get that mapped. And this one's going to be called poles. And let's put it also under electrical. And then we also want our load to show up. So let's get our load map. Now there's already a family parameter built into this family called apparent load. So we have to use it. It will not let us create another one, but that's okay. And then we want load classification is the other one that we want available to our end user. So this one we do need to create. This one lets them decide whether it's general lighting, exterior lighting, emergency lighting. You can pick which kind of load classification you want this light to be attached to. And again, let's put it under electrical. Okay, so those are the only ones we need to map. We don't need to map power factor or power factor state or any of these others. Those can remain in the family because those aren't going to be changed. We can go up to our family types and we can see what we put in here. Electrical, we already had some others, but we have load classification, and it'll get assigned when it gets installed. Number of poles here, the voltage, we can start out with some kind of a default, and then start out with a parent load for a default. Let's get it up here to something like 60 watts just to start with. And then here's all of our dimensions, and we are good to go with this fixture. There, we have everything assigned. Now, we can bring this into our family and see if it works. Okay, here it is. Now, it by default just has all of the poles turned on, and I can go back and change that. But here is what I want to try. We can get rid of these sections I used for something else. Now, first of all, I want to see how this scales. If I change the scale of my site plan, I don't want this to change size. So let's go back to 1 inch equals 20. Now, it may seem like it changed size, but what happened is it stayed the same size and this thing got smaller. So you can see if I get a site plan that's, let's say, 1 to 40, my fixture, the way it comes out of the box, starts to get really tiny. And these stay the same size. So this is what I want. These stay the same size. They're annotative, just like the text. Let's go and try these fixtures out. Now this is a type parameter. So under here, fixture 2, 3, and 4, if I get rid of these, I end up with one fixture. And it's a symbol. We can't see the extrusion. Now you can see it in 3D, which is what we want. You can see it in an elevation, which is what we want, but you don't see it in a plan view. Now go here and try fixture 2. Let's flex this thing. There we go. Try fixture 3. Let's try it without fixture 2. And there you have your 180 degree. So that is how you create a parametric light fixture. Now another thing we can do is notice in 3D that, let's say we don't want to see the foundation that's below grade. Well, do we need to create another visibility parameter all that? Well, not really. All we have to do is go in here, edit type, and then on foundation below, just set that to 0. And as you can see, the bottom of the foundation disappears. And now we just have a nice above grade look. And this can be moved around. It can be moved around vertically. It's not tied to anything. It's not hosted at all. And we have ultimate control over it. So if you like this kind of family editing, I suggest you take a look at this video I'm showing here on the screen to see how to create a non-hosted pendant style light fixture with adjustable pendants. So enjoy. Thanks for watching.